Hi, my name is Omer Nisar. This is my YouTube channel, Think and Grow Rich. You are welcome to my YouTube channel, Think and Grow Rich with Omer Nisar. Now we will discuss the basic concepts of vector algebra, the basic concepts of vector, physical quantities, and scalars, types of physical quantities. So let us start. Physical quantity. What we mean by physical quantity? Physical quantity simply mean characteristics of matter that can be measured, counted is called physical quantity. Characteristics of matter. Matter, what we mean by matter? Dear students, all around the world, of college, of school, of universities, who are here to learn basic mathematics or basic physics. So, what is matter? In simple words, matter simply means anything that occupy space is called matter. For example, here I am standing. I have occupied some space. I have volume. I have height. I have covered some area. Therefore, I am matter. Similarly, whether chairs, table, whiteboard, anything, room, or anything that occupies space is simply called as matter. So after clearing what matter is, now again physical quantity mean characteristics of matter. It means these are the characteristics of matter that can be measured, counted, is called physical quantity. Let's suppose this board is a matter. Let's suppose this board is a matter. And what are the characteristics of this board? This board has length, width. So can we measure length? Yes, we can measure length. And what is length? Length is the characteristics of this board. And what is board? Board is matter. So length is called physical quantity. Width is called physical quantity. It must be remembered that not board but its characteristics such as length, width are called vector quantities, are called physical quantities. Similarly, I am Omer Nisa, not I but my characteristics, and those characteristics which can be measured are called physical quantities. For example, I have a height of 6 foot. It means my characteristics is height, and this height is 6 foot. So height is my characteristics. I am matter. Then height is a physical quantity. Similarly, if I start run, it means I have a speed, and speed is my characteristics. So speed can be measured. Therefore, speed is a physical quantity. Similarly, the room in which I am giving lecture also has occupied the space. Therefore, room is also what are its characteristics? It has length, it has width, it has height, it has area, it has 6 surface areas, it has volume, area, length, width. All these things can be measured. So these are called physical quantities, length, volume. Again, I am saying that matter is not physical quantity, but the characteristics of matter that can be measured, counted, is called physical quantity. So examples are here: length, area, volume, mass, weight, height. Now I put the question in front of you. Can we give the example of such thing that are non-physical quantities? Non-physical quantities. Whether we see it is very difficult to give the example of non-physical quantities. But in this context, I give you an example. Students, Jack, Harry, what you say about non-physical quantity, give me the example of non-physical quantity. Oh, this is not the answer. This is not the answer. So I give you the answer. Love. Love is characteristic of me. I love you. You love me. I hate you. You hate me. But love can never be measured. Has there any machine to measure love? Yes, there are machines to measure blood pressure, to measure the mass, to measure the length, such as scale can measure the length. But has there any machine to measure love, hate, feelings, feelings of expressions? No. Even now, till now, even not a single machine has been discovered to measure hate, love. Can one say that I love you 40 kilogram or I love you 80 kilogram? No, this is a joke. This is a joke. So, love, hate, all these are the characteristics, but never be measured. So we will call them. Here we non-physical quantity mean love, hate, etc. Next, we move to magnitude. What we mean by magnitude? Any number with its unit is called magnitude. Dear students, especially those who are learners of basic physics, basic vector algebra, basic level from 7 to 8, 9, 11, 12, whether in which class, in which grade you are in, but my purpose of creating this video is to deliver the sole message of this vector physical quantities, and I so that I can understand to you, so that I can inculcate the values of these to you, so you can understand the basic concepts of physics. So let's magnitude. Any number with its unit is called magnitude. So this is a number, this is a number, and this is a unit. This number with this unit is called magnitude. So 10 meter is a magnitude. For 10 meter mean this length can be a 10 meter. So 10 meter is a magnitude. Similarly, 7 is a number and n mean Newton is unit. This number with unit is called magnitude. This is called magnitude. Now we come to the point number 2. Physical quantity with respect to its types. Now we will discuss physical quantity with respect to its types. So, those physical quantities which are described by magnitude only. We discuss magnitude here, number with its unit. Those physical quantities which are described by magnitude only are called scalar quantities. And those with both magnitude and direction are called vector quantity. So if one asks what are vectors, we will say those physical quantities which are described by magnitude and direction. So if one asks what are scalar ones, those which are described by magnitude only are called scalar quantity. So let us start examples. Mass, time, speed, energy, temperature are a scalar. Displacement, velocity, acceleration, force are vectors. Let's understand the simple logic. Mass. Why mass is a scalar quantity? Let someone go to shop and purchase sugar from shopkeeper. Imagine, can one say that give me 1 kilogram sugar or 5 kilogram sugar from east side or north side or west side? Is it not a joke? We simply say to shopkeeper, please give me 5 kilogram sugar. We will not tell him direction because it becomes laughing stock. So mass is a scalar quantity. Time. If one asks what is the time, the answer would be there is 3 o'clock, 4 o'clock, 5 o'clock. This would be the answer. 3, 4, 5, 7. These are numbers and these are magnitudes and these are the scalars. While it become imagine if one say there is 3 o'clock but from east side, there is 3 o'clock from west side, north side. This become job. This is not. We always describe time by only its magnitude. So time is a scalar quantity. Similarly, speed is a scalar quantity. Energy, temperature is a scalar quantity. Now we will come to the examples of the vector quantities: displacement, velocity, acceleration, force. All these are the vector quantities. Let us next come to the explanation number 3. Let's understand the difference between displacement and distance. If you are understanding my lecture, if you are understanding my concepts, if you are understanding the physics basics, then you can come on my channel. You can subscribe this channel, and you can also ask questions on comment sections. This video is for you. I am here for serving you. I am here for serving the students of the physics or those who have thirst of knowledge. So you can and this is what, and we must so let us start. Difference between displacement and distance. If it is point A, one has to move from A to B. Then one had two possibility, A to B. If one goes from A to B in straight form, as it has been shown from A to B, and the other person go from A to B in curved path. One person move from A to B in a straight path, just like straight path, and other from A to B in a curved path. This is curved path. And this is straight. So this is called distance. Is equal to S, and it is measured in meter. This is called A to B in straight path displacement. And it is also measured in meter. So what the difference exists between them? This is a straight and shortest. While this is a curved and little bit greater than that. So in between this and this, whose direction is being cleared, whose direction is visible, whose direction we can know. We can know the direction of this because this is straight, in straight line. If one is going in straight line, we can easily define its direction. It is straight line. While the direction of this is being changing, here at this place, here at this place, here at this place, here at this place, here at this place. So its direction is not clearly defined. Since its direction is not clearly defined, it is just like a student who at some time study math, sometimes study at physics, sometimes study at Urdu and English, and indeterminate in making his decisions. So he has no directions. Sometimes he want to become doctor, other time he want to become engineer, other time he want to become English professor, other time he want to become other person. The point is that he is directionless, he has no direction. Same is the case with here. It has no direction. Basically it has no direction. While it has on whole of the journey direction in a straight line, so we can say that this is a vector quantity, this is a vector quantity. Its direction is clear. Since its direction is clear, we call that it is a vector quantity. So displacement is a vector quantity, while distance is a scalar quantity, because its direction is not defined over whole of the journey from A to B. So from here we are able to describe that displacement is a vector quantity because its direction is in straight line and can be defined, while distance has no defined direction over the whole of the journey. Now let us come to the next, velocity versus speed. Velocity is ratio of displacement over time. Speed is the ratio of over distance over time. Here displacement is the vector quantity. From here we know. So displacement is vector and time is scalar. This is vector, this is scalar. There is a rule: if one quantity is vector and other is scalar, while the process is whether division or multiplication, the answer would be a vector quantity. Again I will describe this rule. If there is one vector quantity and other scalar, and the process is being performed is either division or multiplication, the answer would be vector quantity. Same is the case here. Displacement is vector, time is scalar. So this is vector, this is scalar, vector, scalar, and process is division. So we say that velocity, the net outcome would be a vector quantity. So we will put arrow on it. Now come here. Distance is a scalar. Time, distance is scalar. We learned here that distance is a scalar quantity. Displacement is a vector quantity. Distance scalar, time scalar. Scalar over scalar, answer would be scalar. So speed is a scalar quantity. From here we will derive a major difference between velocity and speed. Velocity is a vector quantity, speed is a scalar quantity. Now come to the next. Here, acceleration, change in velocity with respect to time. Since as we know from here that velocity is a vector quantity, so we put vector here, we put vector here. This is vector, this is vector. Vector minus vector, net result will be vector. And this is delta t. So again, this is vector quantity and this is scalar. Vector over scalar, acceleration will be a vector quantity. Now come here the formula number 3. Why force? In force, m scalar, m is scalar quantity, acceleration is a vector. This is scalar, this is vector, then force will be a vector quantity. So force is a vector quantity. Similarly, momentum, mass scalar quantity, velocity vector quantity. So one is scalar, other is vector, answer will be vector. Next, in manual writing, next graphical representation of a vector. Next, graphical representation of a vector. What is graphical representation of a vector? It is defined by this arrowhead. What is this? This is the length, mean magnitude, And what is this? This arrow show direction. So this is vector quantity. In manual writing, when we are writing with manual writing, in manual writing, we put arrow on a vector. While solving paper, by writing on paper, by writing on board, while in book writing, we vector is written in the form of bold-faced. Bold-faced. In manual, in order to, for time saving, we write in simple way. While in book writing, in printing press, book writing, vector are shown in bold-faced letter. And what are the applications of these basic concepts? You can clearly see in curl, divergence, gradient, Green theorem, divergence theorem, Stokes theorem, electromagnetism. This is what all about basics of physical quantities and vector. After all, I come at end of my lecture. I hope that you have understood the basic concepts of physical quantities, scalars, vectors, how velocity and speed different, the difference between these, the acceleration, force, etc. Thank you. Wait for the next video. Your response will inspire my motivation for the next video. Thank you.